Welcome to our study on the derivative of inverse function, and today we are considering the trigonometric function. So we are in part 4 of the derivative of inverse function, and today we want to look at the derivative of the sine x inverse. So given that y is equal to sine inverse of x, find derivative of y with respect to x. So first thing which we are going to do is to multiply both sides of this equation with the sec, both the left hand side. So sec times y will be sec y. On the other side, you have sec times sec inverse of x. Then using the laws of indices, power 1 times power negative 1, we add the indices, so you have 1 plus negative 1, which is equal to sec power 0. Any number power 0 is equal to 1. Then we differentiate this equation. On the left hand side, we differentiate it with respect to x. It is sec y tan y. Derivative of sec y is sec y tan y dy dx, because it is an implicit function. Derivative of x with respect to x is 1. So we divide both sides here by sec y tan y to be left with dy over dx, which is equal to 1 over sec y tan y. We consider this right angle triangle. We draw this right angle triangle here, whereby we have sec y is given by it is given by hypotenuse over adjacent. So we can get the other side, this the adjacent, we can get the adjacent by using Pythagoras theorem. So this side will be x squared minus 1, square root of x squared minus 1, as shown there. So tan y will be given by adjacent over opposite, as shown here. Tan y is equal to adjacent over hypotenuse. Then dy over dx is equal to 1 over x. X is sec y. We are substituting here. Substituting in this equation here. 1 over sec y. Sec y is x. Then times 1 over tan y. Tan y is square root of x squared minus 1. That one there. So we get 1 over x square root of x squared. So the derivative of y is equal to sec inverse of x is given by 1 over x root x squared minus 1. We can also use this trigonometric identity, sine squared y plus y cos y squared is equal to 1. We divide both sides by cos. When we divide both sides by cos, here every term by cos, we will have sine squared y over cos squared y, which is tan y squared, plus 1. Cos squared y divided by cos squared y is 1. 1 over cos squared is sec y squared. So we take 1 the other side, so you'll be left with the tan squared. You'll be left with the tan squared y, which is equal to sec squared minus 1. Now we know from here that sec y is equal to x. So we substitute here. We substitute sec y with the x. So sec y is x. So x squared will give x squared minus 1. So we take square root both sides. Square root of tan y squared is tan y. Square root of x squared minus 1 is equal to that. Then we substitute. Dy over dx is equal to 1 divided by sec y multiplied by tan y. So when we substitute, where you have the sec, you substitute with x multiplied by square root of x squared minus 1. So that is the head of the proof. Hence, given function y is equal to sec inverse x, y differentiated will be equal to 1 over x times square root of x minus 1. So let us go through the process again. What you do, you multiply this side. This equation here is multiplying both sides by sec. So you get sec y, which is equal to sec inverse. Now using the powers of indices, sec power 1, sec power negative 1, you want the index, so 1 plus negative 1 is 0. So sec power 0 is 1. So this sign, that is why here it is x. So we differentiate this equation, it is an implicit equation. So you differentiate it with respect to x. Here, sec differentiated is sec y tan y, dy and dx, because it is an implicit function. This x differentiated with respect to x is 1. So we divide this equation both sides by sec y and tan y to be left with dy and dx, which is equal to 1 over sec y tan y. Now, using a right angled triangle here, this is a right angled triangle. We know sec is given by hypotenuse divided by adjacent. Hypotenuse over adjacent. So tan y is given by opposite. Here, this side is x squared minus 1 using Pythagoras theorem. Square root of x, because it is x squared minus 1 square root. So opposite over adjacent. So we substitute. Instead of sec y, we write x, because x divided by 1 is x. Instead of tan y, we write x square root of x squared minus 1. That way, that is it there. Square root of x squared minus 1, which is equal to 1 over x multiplied by square root of x squared minus 1. So that is the derivative of that inverse function. Alternatively, we can use this identity, this fundamental trigonometric identity, which tells us that square root of y sin y squared plus cos y squared is equal to 1. We divide both here by cos y, cos squared of y to get 1. Here by cos y squared to sin y over sin squared y over cos squared y is tan y squared plus 1, which is equal to sec, squared y, because this is 1 over cos y squared, which is sec y squared. So take 1 the other side, you will be left with the tan y squared, which is equal to sec y squared minus 1. Since we know here, from here, that from this statement, sec y is equal to x, so you substitute sec y, you substitute it with x, and you are going to get, you will get x squared minus 1. Take square root in both sides. Square root of tan y squared is tan y. Square root of x squared minus 1 is this one. That is the square root. Then now we substitute the value of sec y. Sec y is x. Sec y is x from here. From there, sec y is equal to x. So you substitute sec y here with x. Then tan y, we have found it here to be x squared minus 1. So we substitute it here, which is square root of x minus 1. That is the edge. So it means that the derivative of y, function y, is equal to sec inverse x. The derivative is this one, 1 over x square root of x squared minus 1. So bye-bye. Let us keep on learning. Next time we are going to find the square root of, our next activity will be derivative of y, given y is equal to cot inverse of x. So that will be our next study. We are going to do that as we continue learning together. So bye bye. See you then.